Go.
A very good day to all of my viewers. My name is Jerel Tumala and I shoot myself to share to all of you about the inverse function. Based on your previous lessons, what is domain and a range? Domain is the set of all input values or commonly known as the x variable, which produce a valid output from a particular function. It is the set of all values for which a function is mathematically defined. It is quite common for the domain to be the set of all real numbers, since many mathematical functions can accept any input. While the range is a set of all possible output values or commonly known as the variable y, or sometimes expressed as f of x, which result from using a particular function. The range of a simple linear function is almost going to be all real numbers. The domain of of x and range of f of x values can be. But even if you say they are real numbers, that doesn't mean that all real numbers can be used for x. It also doesn't mean that all real numbers can be function values of f of x. Example number 1. Let's make a table of values first. Poste.
Mm.
And here is the original function. We'll just need to do is swap the domains and the range to get the inverse function, just like this. Poste.
Mm.
Sumarong ingon. Sumarong grammar ko.
You did your best.
1, 2, 3,
Mm.
go. To get the inverse function, the domain of the range of y, which is the number 10, you'll put it at the domain of x. Just like this. As you observe, I just swap the numbers of 13 and 10, 7 and 2, 8 and 12, 18 and 15, 18 and 15 to get the inverse function. As what I have said earlier, the domain of the inverse is the range of the original function. The range of the inverse is the domain of the original function. Poste. How about let's have another example. Let's have the number of negative 3 for the domain, negative 3, 5, 7, 10, and 12. And for the range, 8, 6, negative 2, 11, and negative 1. Now, let's find the inverse function. For, posabi, good. To get the inverse function, you'll just need to do is swap the range of the original function into the domain of the inverse. Negative 2, 11, and negative 1. And to get the range of the inverse function, you just put the domain of the original function into the range of the inverse function, such as negative 3, 5, 7, 10, and 12.
Go.
And now let's have the set of ordered pairs for the original function. Negative 3 for domain, positive 8 for range, positive 5 for domain, positive 6 for range, positive 7, negative 2, positive 10, positive 11, positive 12, and negative 1. To get the inverse function, you'll just do the same with the set of table of values.
Go.
And now let's have the inverse of the ordered pairs. You just swap the two numbers to get the inverse. And now we have the inverse function described by the set of ordered pairs.
Okay, so we have now the ordered pairs of the inverse and the original function. I want to give another example, but this time I want you to do it also. Okay, we have here the original function. I want you to get the inverse and the set of ordered pairs of this function inverse also. Okay, time's up. The first thing to do is the range of the original function. We'll put it to the domain of the inverse. We have here 10, negative 8, negative 3, 11, and 9. While the domain of the original function is the range of the inverse function. Negative 7, 15, 5, 6, and 13. So let's get now the ordered pairs. The first thing to do is the range of the original function. We'll put it to the domain of the inverse. We have here 10, negative 8, negative 3, 11, and 9. While the domain of the original function is the range of the inverse function. Negative 7, 15, 5, 6, and 13. So let's get now the ordered pairs. Okay, we're done getting through the table of values. Now let's get it with the set of ordered pairs. Well, I bet all of you got the correct answer. Here is our answer for the table of values and for the set of ordered pairs. You know, this is just so simple. I am giving you a set of exercise. For question number 1, for question number 2, the answer for the question number 1 is the x variables of the original function is 5, 0, negative 3, negative 4, and 3. For the range, the y variables are negative 3, negative 2, negative 1, 0, and 1. And for the set of ordered pairs is our answer for the question number 2 the table of values in the set of ordered pairs. I bet you got the correct answers.